morning, National 5. Because you're all part of the family, I just wanted to share with you a part of my journey in the morning, which is going to school. And I'm going to be cycling, doing a time-lapse GoPro video. This is my home, the one with the lovely garden there, and it's time to cycle to school. Right, I'll see you in class. Guys, just coming in from a good cycle there. That was a good one. I hope you enjoyed the commute with me. But I just have to say one thing, okay? We did it. We did it, National 5. We got to 200 and we're sitting on 214 subscribers. Are you kidding me right now? Are you serious? We nailed the mission to get 200 subscribers by Christmas. We have smashed it, and it's thanks to so many year groups in this school who are sharing and liking the channel and joining the family. Now, I have said to some classes that I will do this. I am going to do another dance. It was so popular at 100 subs. We're going to do another dance, more professional this time, for 200. So that is on the cards because you guys have made it to 200 subscribers. So I say thank you to you guys. All right? Thank you one and all. So, 214, unbelievable. So, dance is coming, all right? I need to figure out what dance I want to do, but it is coming, so do not worry if you are thinking, what is he going to do for 200? I'm going to do something good, all right? So hopefully that makes sense. Now, hope you enjoyed my cycle journey to school. That was a nice wee commute, a time-lapse video, and that is a wee snapshot of my life, which I thought I would give you guys as a extra wee addition for the 200 subscriber mark. But we need to get on to the physics today, and the physics is talking about parallel circuit laws, okay? Parallel circuit laws. Now, just before we do that, I have to do one wee shout out, and that is to a group of S3 who really took us beyond the 200 subscriber mark. And those boys know who they are, and I want to say a shout out to you boys because you guys have done excellent. In fact, they got 100% in their physics test, so I'm going to do that because I said that I would do that for anyone who got 100% in a physics test. Alright, so well done, boys. Right, so we are looking at a parallel circuit. Now, a parallel circuit is a circuit that has two resistors in parallel or lines that are above and below one another. Okay? Now, we're not going to necessarily talk today about how to do examples in a resistor circuit, but we are going to talk about what current and voltage look like in a parallel circuit. Okay? So we're first of all going to do an experiment involving a parallel circuit, looking at current and how current works in a parallel circuit. Okay? So I'm going to pass over to the experiment and you're going to learn a little bit about how current works in a parallel circuit. Alright, I'm going to switch over now. Alright, National 5, here we go with a current in a parallel circuit. I've got the ammeter connected to this point here. This is A, and the reading we get in the ammeter is 0.58 amps. Okay, so now we're going to find out what the current reading is going to be on here, here, and here, and see if there's any difference to 0.58. So what I'm going to do is I'm going to take this one out here. I'm going to then put this and this in here, and put that back. Put this wee wire back into there. Okay, dokie. Right, they're all working again. Wonderful. So now I'm getting, ignore the minus, that's just the way I've wired it, 0.18, okay? So 0.18 now in this one here, okay? So that's different to 0.54 I think it was last time, okay? Right, let's move on to the next one. So let's keep in mind
what that was. And let's just move this up here. And then put this in here. Put it in. Ah, look at this. Again, 0.19, 0.18. So something's happened here. That's the second one we've had of that, but we know that this one was 0.58 or 0. I think it was 0.58 actually. Okay, so something is changing as it goes into these branches. And so the last one we're going to do is take this out. We're going to add this into here. And what we're going to do is add this into here. And let's see what we get here. This time we're getting 0.18 again. So can you see what's happening? This current here is 0.58. These three here are all equally distributed as 0.18, 0.19. So these all add up to the current here. So in fact, current splits in a parallel circuit, and that is the key takeaway here. Okay? Well done.
Okay, you're back. Now, we should have found out, I'm not going to write it in because it's a wee while ago and I can't remember those values, but we should have figured out, and I said it in the video, that every single bit in the current looks a wee bit different this time than it did last time. Remember, current in a series circuit was all the same, but in the parallel circuit we know that at nearest the voltage supply, okay, or nearest the battery, it's at its highest, and then it seems to split as it goes into each branch. But the current will always add back up before it gets to supply again, okay? It splits, so current splits in a parallel circuit, the opposite to what happened last time, okay? Now, in a parallel circuit, what happens to the voltage, okay? So we talked about the current, we'll go back and talk about what that looks like, but what happens to the voltage, okay? So we know that current splits as it goes into different branches, we saw that in the experiment. What now happens to voltage in a parallel circuit, and see if it is different from when we saw a series circuit, right? So I'm going to pass over to the experiment now.
Okay, so this time we're doing voltage in parallel circuit, and I've actually got the voltmeter now connected across the supply voltage. Now, even though it says 4 volts, there'll be some sort of resistance in play here that is resulting in a value of 2.77 volts. But not to worry, let's see how it works when we add it to the rest of the circuit, okay? So what we're actually going to do, I'm going to take this out because this is just a parallel circuit, and we're just going to add it now. It should be lighting all. There's just a wee bit of a loose connection here. Let's see, just make sure that's all working. Doesn't really matter if it's not. This is what happens in a physics experiment. There we go. Okay, right, now let's see what happens when we do this. Keep one in there, and I'm going to do this in here, okay? Okay, and this time I'm getting 2.34. Okay, that's not too bad. Let's see what happens when I do it in the middle one. Again, need to make sure that one light's there, okay? Even if I hold it in place. Okay, this one's 2.3, so only 0.04 off the last one. And almost similar to the one in the beginning. And then, let's move it to the last one. Let's just make sure we get that lit again. Oh, a wee bit different that time. 1.95, almost 2 again. Alright? Now, it's slightly odd, that one's slightly not working, so don't worry too much about that. But the idea still remains. Oh, there we go. 2.14. That's what I'm looking for. Excellent. Right, that's how we hint to you that physics stuff doesn't always work. But anyway, right, what this means is that in a parallel circuit, the voltage across here splits, but doesn't split, it actually remains the same as it goes into each branch. So if this is, what was it, 2.5 roughly. These were roughly 2.5. They're a wee bit lower because of the resistance of the wires, I think, but they should all be the same going into each branch. Okay, so that's a key bit of information there. In a parallel circuit, voltage is the same in each branch as it is the voltage supply. Okay, right, back to the lesson.
Okay, we're back. Right, so in this one we should have seen something slightly different. Remember, voltage in a series circuit all added up to the supply voltage. But in a parallel circuit, the voltages are the same regardless of what branch you're on. Okay? So it's the same regardless of what branch you're on as the supply voltage. So if you have 9 volts, Each branch should be 9 volts, 9 volts, and 9 volts. Alright? Now, we're going to actually pause there. I'm not going to go to resistors, okay, because I don't want to put too much pressure and do too much work all at once, because resistors one is quite an important one. But we'll also then talk about resistors and then talk a little bit about how we answer questions when the circuits look a little bit mixed, okay? But I just want to go back very briefly to this thing here, okay, and just explain to you how this actually works, alright? Now, when we have a voltage supply, okay, and this is key, I really want us to understand what's going on here. If we had a 9 volt supply up here, we have just found out that in parallel circuits, this should be 9 volts, this should be 9 volts, and this should be 9 volts. Okay? Parallel does not change for voltage. However, for current, okay? For current, what happens is, say that the current here is 1 amp. Okay? Actually, no, say it's 3 amps. No, we'll just make it a little bit easier for us. 3 amps. When it comes down, okay, when it comes down, we see that it's going to split at this point here, okay? And say that because these are all equal, you have 1 amp, 1 amp, and 1 amp. We know that it splits because equal for 1 amp, 1 amp, 1 amp. Now, that means at this point here, because it's not split here yet, this is actually 2 amps. And then we know that this one's 1 amp, okay? So when it comes back around here, 1 amp is going to meet with 1 amp, and you're going to get 2 amps. And then 2 amps is going to be with 1 amp, and you're going to get 3 amps. Back to the one nearest the supply voltage. So that's what we mean by current. It splits. Now, if we had a massive resistor, okay? If we had a massive resistor, so say we had 1,000 ohms, and we had 1 ohm and 1 ohm. We know that in this case, regardless of what happens, the voltage is still going to be the same in each. 9 volts, 9 volts, 9 volts. But the current likes to go in the path of least resistance. Okay? So you're going to get more current going through the 1 ohms because it wants to go through the path of least resistance than you do with the 1,000. Actually, hardly any current will be going through the 1,000 ohm resistor. Okay? So I just want to make that very clear about how that actually works. Because the questions I'm going to put at the end of this are going to be looking at how we actually put current and voltage and look at parallel circuit and actually answer the questions on that. Okay, right, that is me for today. National 5, short and sharp, but 2 more experiments under our belts, and we now know how current and voltage work in series circuits and parallel circuits. That there is the foundation for not only National 5 physics, but for higher physics and for any electronics in the future. Okay, now, we're in the middle of November. We're possibly going into, well, we are going into Tier 4. Alright, these videos are going to keep us happy, keep us excited, keep us encouraged, but I hope the dance that's coming up will give you a little bit of a laugh. And National 5, I just want to say thank you for being a part of the family. Like, share and subscribe, and I hope to see you next week once again. See you later, National 5.